In this video, we're going to apply chain rule. So let's say you have y equals f of g of x. If you want to take the derivative of this, it's going to be the derivative whole thing, which is f prime of g of x times g prime of x. And we sometimes call this outside-inside rule. So for example, let's say you have y equals 3. Quantity x squared plus 1 to the second power. If you want to take the derivative of this, and if you want to apply the chain rule, you take the derivative of this whole thing. So 2 times 3 will be 6 times the quantity x squared plus 1. 2 minus 1 is 1. And then you got to take the derivative of inside, which will be 2x. So now you get 12x quantity x squared plus 1. If you did not want to take the chain rule, we could multiply this out. So for example, this means you have 2 of x squared plus 1. So you multiply this out and you end up getting x to the 4th plus 2x squared plus 1. And you distribute the 3, you get 3x to the 4th plus 6x squared plus 3. That is your y. Notice we didn't take the derivative yet. We wrote it. Now we're going to take the derivative. You end up getting 12x cubed plus 12x and then plus 0. Notice when you distribute the 12x, you get the same thing. But chain rule is powerful because you cannot multiply out the factors all the time. And this is what I mean. Now let's say you have y equals sine of 3x. How do you find the derivative of this? Well, the derivative of the whole thing right here will be cosine of 3x. Now, what's inside sine? It's 3x. What's the derivative of 3x? It's 3. So times 3. So you end up getting 3 cosine of 3x. Be careful not to distribute the 3 and you get 9x. That is not mathematical. So you have to put 3 outside the cosine of 3x. What if you have y equals sine cube of 3x? Before we take the derivative, let's rewrite this. Y equals quantity sine of 3x to the 3rd power. Notice I just rewrote it. These two are the same thing. Why? So that it's easier to find the derivative. So let's find the derivative of y. What's the derivative of the whole thing here? It will be 3 sine of 3x. 3 minus 1 is 2. Now, don't forget to find the derivative of inside. What is the derivative of sine 3x? We found it earlier. It is what? It's going to be times cosine of 3x, and then it was times 3. So you got to be careful. So make sure you understand where this came from. So you end up getting 3 times 3 will be 9. You have sine squared 3x times cosine of 3x. That is a derivative of sine cube of 3x. Now we got g of t equals tangent of quantity 5 minus sine 2t. So this is inside the tangent. Well, let's find the derivative inside. Let's call this y. Y equals 5 minus sine of 2t. So what is the derivative of y? Well, derivative of 5 is 0. Now, what is the derivative of negative sine of 2t? Well, derivative of negative sine is negative cosine of 2t, but don't forget the derivative inside. What's the derivative of 2t? That's 2. So you're going to get negative 2 cosine of 2t. So that was a derivative inside. Now, what's the derivative of the whole thing? So if you want to find the derivative of g prime of t, then you're going to get, what's the derivative of tangent? The secant square of this, phi minus sine of 2t, times the derivative of inside, which we already found, is quantity negative 2 cosine of 2t. So negative 2 can go in front, so let's put negative 2 cosine of 2t, secant square quantity phi minus sine 2t. That will be the derivative of this problem. Now, if you think about it, right, you've been doing chain rule all along. Think about it. Let's say y equals x squared, right? What's the derivative of x squared? It's 2x, isn't it? 2 times x. But what's the derivative of x? It's 1. So it's 2x times 1, which is 2x. So basically, you've been doing chain rule all along, but now you really get to see chain rule in action. How would you find the derivative of f of x? Well, one of the method is you could change it to f of x equals 1 over quantity 3 minus x cubed, and then to the fifth. And you could apply the quotient rule, but rather than doing that, which will be a longer method, let's just apply the chain rule right here. So derivative is going to be negative 5 times 1, which is negative 5. Quantity, 3 minus x cubed. Negative 5 minus 1, which is negative 6. Times derivative of inside, which is negative 3x squared. So you end up getting negative 5 times negative 3 is 15 x squared quantity 3 minus x cubed to the negative 6. You could leave it like this. However, if they want the answers in positive exponents, you could write it as 15x squared over quantity 3 minus x cubed to the 6th power. And you should realize that these two are the same thing. Now let's find the derivative of f of x, which is 3 radical quantity x squared plus 1. So in order to find the derivative of that, we first want to rewrite it as 3 quantity x squared plus 1 to the 1/2. Now we need to apply the chain rule. So derivative of that will be 1 over 2 times 3, which is 3 over 2, times the quantity x squared plus 1, and then 1 over 2 minus 1 will be negative 1 over 2. Now we're not done yet. This is a common mistake. A lot of students stop right there. But we have to apply the chain rule. So you have to find the derivative inside. So times 2x. Now let's clean this up. 2 and 2 cancels out here. You get 3x. Quantity x squared plus 1 to the negative 1/2, which is the same thing as 3x over x squared plus 1 to the positive 1/2, and which is the same thing as 3x over radical x squared plus 1. Now we're going to take a look at the last two examples. First part says find the slope of the line. Slope of the line tangent to the curve y equals sine to the 5th of x at the point where x equals pi over 3. So basically we just need to find the slope of the tangent line, not equation of the tangent line. So we got y is quantity sine x to the 5th. And what is our derivative? dy over dx. Well, we have to apply the chain rule. You get 5 quantity sine x to the 4th. The 5 minus 1 is 4. Times, don't forget, you got to find the derivative inside, cosine x. But we're not done yet because we got to find the slope at x equals pi over 3. So we got to plug in pi over 3 for x. Now, what is sine of pi over 3? That's radical 3 over 2. So 5 times radical 3 over 2 to the 4th power. What is cosine of pi over 3? That's 1/2. So you get 5 times, that becomes 9 over 16. So you end up getting 45 over 32. So the slope of the tangent line of this curve at x equals pi over 3 is 45 over 32. Now part B says show that the slope of every line tangent to the curve y equals 1 over quantity 1 minus 2x to the third is positive. So let's find the slope of this curve. So dy over dx is, okay, before we do that, let's rewrite this so that it'll be easier to find the derivative. So you could rewrite this as quantity 1 minus 2x to the negative 3. Otherwise, you have to apply the quotient rule. It gets more messy. So now, take the derivative of that. What do you get? You get negative 3 quantity 1 minus 2x, negative 4 times the derivative of inside, which is negative 2. So you end up getting positive 6 quantity 1 minus 2x to the 4th power. I'm sorry, negative. But if you want to make it positive, you can rewrite this as 6 over quantity 1 minus 2x to the 4th power. Now notice, denominator cannot be 0. So when you set 1 minus 2x equals 0, you end up getting x equals 1 over 2. So x can never equal to 1 over 2 in order for this the slope to exist. However, besides 1 over 2, you plug in any number here. Since you're raising to the 4th power, this will be positive. Just think about it. Plug in 0, plug in negative numbers, plug in any positive number besides 1 over 2. You'll always get positive here on the bottom. Since the numerator is positive, and positive divided by positive is positive, therefore, we show that the slope of every tangent to this curve is positive.